Hello everyone. In this video I'm going to do some MC questions about the relation between arc, chords and angles. In this example, first of all you need to understand this clearly or how to get the information from this line. In my opinion, I will read the coefficient of the numbers here 1, 1 and 3, and I would like to multiply the numbers to the same values. Say for an example, the number in front is 1, 1 and 3. So if I multiply 3 to the 1, multiply 3 to 1 and just have no change, then all numbers, or just multiply to 1, then all numbers are in front are 3, right? And the number 3, 3 and 1 are actually the ratio of the arc lengths of AB, BC and CD. So that means when I get this piece of information, I can write down the arc length of AB, BC and CD are of this ratio 3, 3 and 1. Okay? And next, we want to make use of the angle 126 degrees. So we can say that 126 degrees is the angle at center from 2 points A and D. And in A and D, the arc lengths are of 7 portions. And since we know that the arc is proportional to the angles at center, so we can find out the angle at center of each portion of arcs. So if we get 126 divided by 7, we get that for each portion the angles is 18. But we want to find angle AED. It's not the angle at the circumference, so we need to relate this angle to angle at center twice angle at circumference, or even angles in the same segment, etc. Now, if we join some lines, like if we join say BC, then the angle AC boy is the angle at circumference from the points A and B, and the arc length of AB are 3 portions. Do you still remember just now we found that the angle for each portion is 18 degrees at the center? So if we multiply it by 3, we know that the angles is 54 degrees at the center. So at the circumference it should be 27 degrees. Okay? And similarly, the angle C boy dot is the angle at the circumference from the 2 points C and D. And C and D, the arc length of C and D are of 1 portion, that is 18 degrees. So the angle at the circumference should be 9 degrees. So you know that by exterior angle of triangle is 36 degrees, and by adjacent angles on straight line is 144 degrees. Okay, 144 degrees. So the answer is C. Okay, so this is example 4. Now example 5. Example 5, AC is a diameter of the circle. For diameter, you need to think about angle in semicircle or something related to center of circle. But there's no center of circle is given, so we may focus on the angle in semicircle. And also, there's no such triangle constructed, so we need to add some lines, but we don't know which line should be added. Now, AD and BD are equal chords. AD and BD are equal chords. Whenever there are 2 letters being the same, that means we can form an isosceles triangle also. Okay, so you may consider equal chords property, or you can consider base angle is isosceles triangle if you join AB. Now, angle CAD is 36 degrees, and you need to find angle ADB. In this case, you may think of joining CD, because you know that 36 degrees, this angle is quite related to the triangle ACD. And you may also think about to join BC, because we have 4 points on the circle. BD intersect AC at the point E, so that we can have angles in the same segment. And also you may think about to consider to join AB, because we can have base angles isosceles triangle. So you may need to figure out which way is the best for you. Okay, so you need to try more, but in this case I will try to first join BC first, because I can immediately have this angle being 36. And then since the two chords are given to be equal, so we need to use it. I need to join AB as well. And after I have joined AB, angle ABC is 90 degrees, angle in the semicircle. And so we get this to be 54. And this whole angle is also 54, because base angle is isosceles triangle. And we can consider to find triangle ADB by angle sum of triangle. And so the answer here is 72 degrees. Okay. Example 6. Example 6, you are given O being the center of the circle, and AB, BC arc lengths are of ratio 4 to 3, and AC boy is 32 degrees. Okay, you need to find angle BOC. First of all, the angle ACB is the angle at circumference joined from the 2 points A and B. Okay, it's of 4 portions, angle at the circumference. And thus we can relate the arc proportional to angles at circumference or at center. But since it's up to you, yeah. Angle at circumference is 32 degrees of 4 portions. What about for 3 portions? That means for each portion is of 8 degrees. So for 3 portions, we know that angle boy AC is the angle at circumference joined by from 2 points B and C. So it's 24 degrees. And from the same points B and C, angle at center is twice the angle at the circumference. So the result here is 48 degrees. So the answer is B. Okay. Now example 7. Example 7, you are given two angles 15 and 60 degrees, and they are both angles at the circumference. So the corresponding arc lengths are of ratio 1 to 4, or 15 to 60. So the corresponding arc lengths would be BC and BD here. Okay, so we know that CD is 24 cm, and since we know that BC to BD is 1 to 4, so BC to CD is 1 to 3 instead. And now for 3 portion is of length 24, for 1 portion is of length 8 cm. So the answer is A. Okay, it's an easy question. Example 8, last example here. You are given a relation like this, and you just need to find angle AE boy. Okay, you are not given any angles. And the same as example 4, when you meet this kind of equal relation, what you need to do is to try to make the coefficients before the arc length the same. So you know that for the numbers 3, 2, 6, and 3 is the most convenient for you to get all numbers to 6 by multiplication. So you multiply by 2, 3, 1, and 2 respectively. And these numbers 2, 3, 1, and 2 gave us the ratio of the arc lengths AB, BC, CD, and DA are of ratio 2. AB is 2, BC is 3, CD is 1, and AD is 2. Okay, and if it's not specified, all arc length here are referring to the minor arc. Okay, and now you need to find angle AEB, that is here. It's not an angle at center nor at the circumference. Okay, so we need to make use of the arc proportional to angles at either the circumference or the center. Okay, and since there's nothing related to center is given, so I opt to use the angle at the circumference. Okay, so now for the arc length 2213, we all know that the whole circle are of angle 360 degrees, right? So the angle at the circumference, the total sum of the angle at the circumference is 360. So that means angle at the circumference is 180. So if we consider the number of portions here, 3, 2, 2, 1 is 8 portions. So if we consider 180 degrees, that means the total angles at the circumference is 180 divided by 8. Okay, for each portion is 22.5 degrees. And if we try to find the angle related to angle AE boy, you may think that you should consider triangle A boy E. And angle A boy E is the angle at circumference from the 2 points AD of portion 2 of its arc length. So for one portion being 22.5 degrees, two portions should be 45 degrees here. What about this? This angle here is the angle at circumference from 2 points B and C. It's of portion 3, so we should get 67.5 degrees. And then you can find the required angle by the angle sum of triangle. And so you can find 67.5 degrees as well. Okay, 67.5 degrees as well. Okay, so that's all for this question. But then if I would like to have one change on this question, I may change it to maybe a kind of 1, 2, 3 question, and asking you to determine whether the chord AB is the same as the length of chord B, the length of the line segment BE. Okay, and the answer is yes, obviously. Okay, so that's all for this example, and that's all for the online learning series. And you may come back to school at on 27th, 27th of May, and yeah, see you all there, and thanks for watching.